And in 3.3, if you see, it's just all evaluating. So there's no word problems here. It's just kind of a like motion that we're doing today. So we're doing something I call a log roll. I don't know what other pre-cal teachers do it, but I must have learned this from somebody sometime. So I'm just going to teach it to you guys. We have been doing exponential functions, but we're joining in log functions today. So an exponential is like something raised to an exponent equals another number. When you go into log form, it's written as log base b, or base a number, of something equals the answer. So I read this as log base b of y, and then I would say equals x, or whatever that is. I know you guys have a basic understanding of logs and exponentials, but I think I said this earlier. I feel like this is something like all of us as math teachers just kind of skim over, so you may not have as deep of an understanding as you would like. What we're doing today is we're going from log form into exponential. So when I go from log form to exponential, I do something called a log roll. I'm like rolling around the equation. I start on the first number you see, so if it's log, that's a function, that's not a number. So b is the first number we see, and then I wrap around to the other side of the equal sign and then loop back through. It makes this big cursive E, which reminds me that that's how I get into exponential form. So if I'm in log and I want to go to exponential, I draw this fancy E. And if you see, that's the exact same thing I wrote above. So b raised to the x equals y. B raised to the x equals y. So you can switch between both forms by doing this log roll. If you do it backwards, it's the same idea. If I go from exponential to log, we don't do that today, and I still call that a log roll, but I make an L instead to remind myself I'm going to log. So I would still start at B, I'd go to Y, and then I'd loop back to X, which looks kind of like a big L. Again, other teachers might teach it differently, but I'm gonna focus on the red log roll that we were just doing in what we're doing today. And so let me just walk through a few of these, and maybe once we've done a couple, you're gonna be like, oh yeah, I know how to do this, or oh, I remember this. But there's a ton of examples, so we're gonna work through a ton of different types, some properties of exponential problems, those kind of things. So if I start at letter A, I've got log base 5 of 5. In order to do a log roll, I need something on the other side of the equal sign. So I've got log base 5 of 5 equals 1. So when I log roll, I go from 5 through to x and then back to 5. So I'm able to rewrite this as 5 raised to the x equals 5. I don't know if this doesn't explicitly say no calculator, but when I evaluate, I'm not using a calculator. So I have no idea what log base 5 of 5 means. But if I rewrite it in exponential form, I can think, oh, 5 raised to what power equals 5? Well, 5 to the first power is the same thing as 5. So x has to equal 1. Next one's very similar. I'm going to set it equal to x. I'm going to start at 4, and then I'm going to wrap around. 4 raised to the x equals 16. Okay, 4 to what power equals 16? Oh, I know that 4 squared, or 4 to the second, is 16. So my exponent is 2. I'm going to pause right now. Does anyone have any questions on what I'm doing so far? Okay, I'm gonna keep going. I'm probably gonna do every single one of these problems. If you think that we're good, we can skip ahead, but my last class wanted all of them done, so it's totally fine. We'll keep going. They're the same motion, so I'm gonna keep doing this log roll. But on this next one, you see that we add something different in. I have an ln. Remember that ln is the same thing as natural log, and ln is the same thing as log with a base of an e. So E is that special number. It's like 2.78, blah, blah, blah. Maybe next semester I'll spend a little bit more time talking about what E means so we understand it. Some people still think E is a variable. It will never, ever, 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 ever be a variable. Instead, though, I can rewrite this instead of ln, I can write it as log base E of E to the 10th. Okay, set that equal to x like I've done all the other ones. And then let's log roll. I'm gonna do e to the x equals e to the 10th. When I get this, this is actually super easy for me to solve because their bases are the same. It's e to something equals e to something else. That means that their exponents have to be equal to each other. X has to be raised to the 10th power. Or x is 10. E has to be raised to the 10th power in order to equal 10, x to the 10th. I've got another ln on the next step. So I'm gonna write log base e. Now I've got this cubic root of e. Remember when you have a radical, it makes a fraction as your exponent. So I'm gonna say e to the 1/3. So when you have a fraction, the number in, or sorry, if you have a radical, the number in that radical goes on the denominator. And then if there's any power on the inside, that goes to the numerator. There's no power here, so I just leave it as 1/3. That equals x. Log roll, e to the x equals e to the 1/3. That means my exponents are the same, so x equals 1/3. Okay, I'm gonna pause for questions. Okay, don't be afraid to speak up. If you don't know how I got something, please, please, please tell me. I'm gonna just keep rolling though. The next two are similar to each other. Now, this one I wish I had a better explanation. The only thing I can tell you is when you have a number that's being raised to a log with base the same number, those all cancel out and you're just left with whatever we were doing the log of. So my answer here is just 10. Everything else cancels itself out, and so all we're left with is with 10. The next one's the same. It's 8, and it's being raised to log 8. So that means those cancel out, and I'm left with 2. Okay. Letter G is a little bit different because it has a 4 in the front, but it's not 4 raised to the log, it's just 4 times. Whenever you have a 4 times out front, or any number times out front, it's not just 4, that is an exponent on the number that we're doing the log of. So you can move that to be 2 to the 4th instead of that 4 out front. We're gonna log roll the exact same way. 2 to the x equals 2 to the 4th. Again, that 4 out front became an exponent that I took to the back. And the bases are the same. They're both base 2, so that means x equals 4. Letter H is e raised to the ln. Oh, well, ln is the same thing as log base e of 6, and I've got a number that's being raised to log with base the same number. So those cross out, and I'm left with x equals 6. Not a lot of work on those. Oh, that's not at all what I wanted. That's okay, whatever. Okay, any questions so far? 2 more in this column and then we'll go to the next. Also set it equal to x, we've been doing that all day. 8 to the x equals 1. Well, any number raised to something will always be 1. That something, that number that is in the exponent, that no matter what is the base, will equal 1 is 0. So any number raised to the 0 power is going to equal 1. And then last, I have just a square root, no number with that radical. Don't forget that that's the same thing as 7 to the 1/2, just like we did, now I'm zooming way far away than I thought. Like I did on letter D, the cubic root became e to the 1/3. If there is no number with that radical, we assume that it's 2. We assume it's a square root. So that's the same thing as 7 to the 1/2. So I've got log base 7 of 7 to the 1/2. And so, oh, don't forget to set it equal to 0, or not equal to 0, equal to x. And 7 to the x equals 7 to the 1/2. 7 to the x equals 7 to the 1/2. And then again, my bases are the same, so then that just means I get to set my exponents equal. Okay, we just did a ton of examples on this side, and we're gonna do some very similar on the other side, and also explore a couple other concepts. So a couple big ones we've talked about were just normal exponents, raised to the first, raised to the second. If you look at like D and G, we had the radicals, and that makes a fraction exponent. And then E, F, and H were all the same, where I wish I had a better explanation, but if you have a number that's being raised to log base that same number, then we're just left with the final number that hasn't been used. So we're left with the 10 in E or the 2 in F. Okay, I'm going to erase this part over here because I don't need that anymore. That gives me a little bit more space to work. So again, we looked at a ton of concepts on the left. We're gonna add those and a couple more on the right. The first new concept we're looking at is if we don't have a base. So if it says log of 1,000, or of 100, excuse me, there's no base, we assume that that base is 10. So log without a base is always just 10, base 10. Again, set it equal to x, so we can do our log roll. Base, roll all the way around and cut through to make that cursive E. And so I get 10 to the x equals 100. And we ask ourselves, what number does 10 need to be raised to get to 100? And we say 2. Any questions so far? Remember to speak up if you need to. And if not, I am recording this. So if you need to like go back and stop and pause and rewind, feel free to do that on YouTube later. Or ask me and we can do a Zoom sometime. I'd love to help. All right, letter L, I've got something funny here. I've got a fraction, not a radical like I do in letter M, but a fraction. Let's log roll and see what happens there. I've got 3 to the x equals 1/9. Oh, well, 1/9. We can't do anything unless we have a base 3 on both sides. That helps us solve. So I can make 9 into be a base 3. We know that 3 squared is 9, so I can rewrite that as 1/3 squared. Oh, but that's still not base 3, that's technically base 1/3. If we want to flip it to make it a 3 on top, so 3 to the x equals 3, it would have been a negative exponent to get us there. You don't have to show all these steps. You can go immediately from here to there. But what I had to think through first was, okay, if it was equal to 1/9, that's the same term as 3 raised to what power? Well, to be on the bottom of the fraction, it would have been negative, and then to be 9, it would have been squared. And the reason this is helpful is now I just have 3 to the x equals 3 to the negative second. The only way for that to work is if x equals -2. X equals -2. We're gonna do a couple more like that. So if that's confusing, stick around. I see N and O both look like that too. Oh, but M's another radical. We've done that a couple times. We can do that. Remember, radical of 3 is the same thing as 6 to the 1/3. So we've got log base 6 of 6 to the 1/3. Don't forget to set it equal to x so we can do our log roll. 6 raised to the x equals 6 to the 1/3. That means that my exponents are the same, or my bases are the same, so that means my exponents have to be congruent or equal to each other. Oh, sorry, not congruent. I'm like in geometry talk right now. Equal. That was weird. Okay, questions so far? All right, 1, 2, 3, 4, 5, 6. 6 more. This may, 7 more, I lost that one. Again, it may feel a little tedious, but the more we practice this, the easier it's gonna come later on when you do it by yourself. N, I know it's a little hidden in there, it says ln of 1 over e to the third. Well, ln is the same thing as log base e, and then 1 over e to the third, we can write that as e to the negative third. Don't forget that's equal to x, and the equal to x is important so we can log roll. So I'm going to do e to the x equals e to the negative third. My bases are the same again, so I just get to set my exponents equal. All right, got another fraction one. Set it equal to x. 4 to the x equals 1 over 16. Since we just did that one with 1 over 9 a minute ago, we can go pretty directly to the next step. If I know that it's 4 to the x equals 1 over 16, well, 16 is the same thing as 4 squared, but since it's in the bottom of a fraction, it's 4 to the negative second, or 4 to the negative 2. That gives me x equals negative 2. Oh, come back. Got a couple log base 10s to kind of round this out. 10 raised to the log of 7. Well, remember that's log base 10. And what we did on the other side with the columns, if these numbers are the same, then that means that they cancel each other out and I'm just left with 7. X equals 7. Log of 1,000 is the same thing as log base 10 of 1,000. So I do my log roll, 10 to what power equals 1,000? We know 10 to the second is 100. 10 to the third is 1,000. If you have to check that in your calculator, feel free to. Reminder that or at least a shortcut that I use, is that whatever the power is for 10 is how many zeros you have. 1, 2, 3 zeros to the third power. That's something that kind of helps me. It's not a super technical skill, but it is a shortcut, and we all appreciate a shortcut. All right, 3 more. I've got 2 log base 3 of 9. Remember when we have that 2, it becomes an exponent to my 9. So I've got log base 3 of 9 squared, again set equal to 0, so I can do my log roll. 3 to the x equals 9 squared. You can do what 9 squared is and then decide what 3 raised to what power is. So I know that 9 squared is 81. So I can say, okay, 3 to what power is equal to 81? Or you can think about breaking that 9 down to base 3. Nine squared, let me do it in a different color. 9 squared is the same thing as 3 times 3 and 3 times 3. So that is 4 3s. So 9 squared is the same thing as 3 to the 4th. And that makes it super easy for me to know that x equals 4. You would also get it if you did it this way. I just don't know the multiples of 3 off the top of my head very quickly, so I would have to use a calculator. So if you want something a little bit more fast, you could also do it by factoring. Similar idea for the next one. I'm going to bring that 3 out to the exponent. So instead of being in front, it's going to become that exponent equal to x, so I can log roll. 2 to the x equals 8 to the third. Again, you can do what 8 to the third is. I believe yesterday we decided it was 512. Or you can do a little factor like I did on the last one. So if it's 8 to the third, that means I have 3 8s, and 8s are made up of 3 2s. 2 times 2 times 2, 2 times 2 times 2, 2 times 2 times 2. And that is 3, 6, 9 2's. So that's the same thing as 2 to the x equals 2 to the 9th. In either direction, you'll get 2 raised, or x is going to equal 9. Last one's a softball. It says e raised to the ln 4. ln and e cross each other out, and so x just equals 4. Okay, I know I just did a lot of talking, and I know that there's a lot written here. This isn't, I don't think, hard math, but you need to get in the habit of that log roll and rewriting it from log form to exponential. Does anyone have any questions so far? Okay. We're gonna do the next part, which is very, very similar. The x is just in a different place now. I'm still log rolling, I'm still solving for x, it's just now in a different location, which makes the solving look a little different. Let's explore that, okay? So it says solve the following. Log of x equals 3. If there's no base, we assume it's base 10. And again, I'm gonna log roll. 10 to the 3rd equals x. Oh, well now my solving is just knowing what 10 to the 3rd is. That's not hard. If I don't know, use your calculator. If you do know, 10 to the 3rd should be 1,000. Remember the hint I just told you? Exponent is how many zeros? 1, 2, 3. Feel free to use that hint. Ooh, stop. Okay. Next one, similar idea. Log of x equals -1. So that's the same thing as log base 10 of x equals -1. Log roll. 10 to the -1st equals x. Now, your -1st, you can do this one of two ways. You can make it a decimal or you can keep it a fraction. My first thought is I'm better with fractions. I know that a negative makes it go in the bottom of a fraction and it's just 10 to the 1st. So that's the same thing as 1 over 10. You can also think about fractions and moving decimals and all that fun stuff. If I have 10 to the -1st, that's the same thing as 0.1. And so either answer is acceptable. Just how your brain decides it wants to work. Okay. Next I've got C, log of x equals -2. So I've got a log base 10 again, log roll, 10 to the -2nd equals x. Again, you can leave it as fraction, you can leave it as decimal. As a fraction, it'd be 1 over 10 squared, which is 1 over 100. And as a decimal, it would be 0.01 equals x. All right, the next couple are a little funky. They've got this ln. And again, you'll have a couple options on how we write this. ln is the same thing as base e. So I can do my log roll, e to the 4th equals x. And that's a totally acceptable answer. You can leave it there. Or you can put this in your calculator and find out what x is going to be. E to the x, e to the 4th. Remember that you can do second ln, and I'll just press e to the 4th, and I got 54.6. If we have time at the end, I'll show you some calculator stuff, but essentially all I did was plug it in. I know this is very janky for me to do during class, but that's what I see. Again, you could just leave it as e to the 4th equals x. That is also completely acceptable. And then last one in this column, ln of x equals 6. Again, log base e to the 6 equals x. E to the 6, keep on your x, equals x. And again, you can leave it like that, or you can leave it as e raised to 6, which is 403.4. Both are correct. All right, we're gonna look at the next one. So let's start solving that. It looks like I've got something different here. I've got an exponent. So let's look at what that means. The 3 out front means that my exponent goes to the x. There's no log, or there's no base, excuse me, so we assume that that's base 10. So as I log roll, let's see what happens. I've got 10 to the third equals x to the third. Okay, that makes sense from our log roll, but now I don't actually have to plug anything in to solve. I just can look at this, and whatever the base is on the left, 10 to the third, well, the right side says x to the third. The only number that would work there is 10. You can't plug 5 in. 5 to the third is not the same as 10 to the third. There's no other answer than just the exact answer that you have on the other side. It's just got to be a mirror image. Okay. Any questions so far? All right, let's keep rolling. The next one has an exponent, it looks like, as well, but this time its exponent's a -2. Oh, what's that going to do to it? Color coordinate. A -2. It's e, log base e, because ln's log base e. E to the 4th equals x to the -2nd. All right, this is messy because I need to get x by itself. So there's a couple ways that you can do this. I think the easiest way is to start with the x, and I don't want that to be a negative exponent. So if I make that e to the 4th equal to, I can make x to the -2nd to be x to the 2nd, x squared. Once I do that, I can now get rid of the fraction by multiplying by x squared to both sides, or by cross multiplying. Again, there's a little bit of finagling we're doing in order to get it to be what we want it to be. E to the 4th equals x squared times 1. Okay. Now, the last thing I want to, or the 2 last things I want to do is I got to get that x by itself. So let's divide by e to the 4th. So I've got x squared equals 1 over e to the 4th. And then my last step is to square root both sides. X equals, okay, square root of 1, oh, that's just 1. Square root of e to the 4th. If I have e to the 4th, that's e times e times e times e, 4 e's. 2 of them get to match together, 2 of them get to match together, which means, I don't know if you guys remember factor trees if we've done those recently enough, but e to the 4th, e, these 2 get to get matched up, so I have 1 e that comes out, and then these 2 get to match up, so I've got another e that comes out. E times e is the same thing as e squared. So it's x equals 1 over e squared. Ooh, we haven't had to do that much work on any of the other ones. So sometimes they require a few more steps. Sometimes they are pretty simple. I'm going to leave that there for 1 second because I know that that's a little confusing. Anything so far from me? You guys doing okay? Okay. We've got a couple more, and these are fractions. So remember, when they're fractions, that means that I have a radical. I have some kind of exponent. So we got to deal with that exponent right now. Or sorry, some kind of radical. I don't know why I said exponent. Log of x equals 1/2. So remember, that's a base 10. Let's do our log roll, and then we'll talk about what that means. So that's 10 to the 1/2 equals x. 10 to the 1/2 equals x. With 1/2, sometimes you guys are like, oh, well, that's like 2 to the negative first. Well, that's a lot for an exponent. So the 1/2 is my exponent. And as we were just doing on the first page, whenever we had an exponent of 1/2 or 1/3, it came from a radical. So 10 to the 1/2 is radical 10 equals x. You don't need to do plus or minus because we didn't physically square root both sides. It just was already there, so no need to plus or minus. And 10, you can't simplify. I can't do like a factor tree for 10 because it won't work. It won't give me anything out. So that's the best answer. Similarly for the next one, but this one's a 1/3 is my exponent. So 10 to the 1/3 equals x. Instead of a square root, it's still a radical, but it's got a little 3 out front because it's a cube root now. Again, cannot factor tree. There's not any perfect cubes in 10, so we're going to leave that as it is. And then the last one, I've got ln of x equals 1/4. ln is base e. Let's roll. E to the 1/4 equals x. Well, e to the 1/4, just like 10 to the 1/2, 10 to the 1/3 is going to be a radical, but this time it's a 4 out front and just the e on the inside. You are welcome to put that in the calculator and get an actual answer, but you are also welcome to just leave it as it is, and I'm just going to leave it as it is. Okay. Any questions at all? Again, we just finished 3-3. This is the last section we're doing this semester. And I am not assigning that homework. So you are welcome to do it. You are responsible for knowing this, but you do not have to turn in 3-3. You do not have to get a grade for 3-3. It is just your personal practice. I did already assign 3-1 and 3-2, so make sure that those get in if you can. And then also remember what we talked about at the beginning of class about how the quiz will be optional. I'm going to send an email shortly with details like that it will be on Schoology, that you need to resubmit it to me, that you can choose not to submit it, that, I don't know, any other details. And again, if you have any personal requests, things, just let me know. I'm going to stop my share because I don't think we need to be here anymore. And I will